So for earthquake lab number 1, and also to find the actual epicenter of an earthquake, we're going to do earthquake number 1 together. So this is a seismograph, and these are, these are broken up just like your ESRT. And these big bolded lines here are minutes. So this is 20, 21, 22, 23, 24. So our P wave arrival time for Denver, Colorado is 5:24. You're going to put that on the bottom here, 5:24. And your S wave arrival time is 25:26, and it's actually one past that. So it's 5:26:20. We're going to fill out the rest of this first, and then we'll go through the other information. So for Dallas, the P wave arrives at 5:25 in 0 seconds. The S wave, 26, 27, 28, 28, and 20 seconds. So 5:28, 20. And then for Salt Lake City, P wave arrives at 21, 22, 5:23. And then the S wave arrives at 5:24, and this time 40 seconds. All right, so now we need to find the difference in arrival time. So to do that, you're going to want your scrap piece of paper. Remember, it's always S wave minus P wave. So we have 5:26:20. And we're going to subtract our P wave. So we look at the seconds column first. So it's going to be plus 20 seconds there. And then 26 minus 24 is 2 minutes. So we're going to add those together. So our difference in arrival time here is 2 minutes and 20 seconds. All right, our next one is Dallas. So our S wave is 5:28:20, and we're going to subtract our P wave. Again, starting at our seconds, it's going to be plus 20 seconds, and then 28 minus 25 is 3 minutes. So our difference here is 3 minutes and 20 seconds. Oops. And then last but not least, we have Salt Lake City. Our S wave is 5:24:40, and our P wave is 5:23:00. This time it's going to be 40 minus 0, which is 40 seconds. And then this is 1 minute. So our difference is 1 minute, 40 seconds. So now that we have our difference, we now need to find the distance to the epicenter, because that's how we are going to find the actual epicenter of the earthquake. So you're going to need page 11, and you're going to need scrap. All right, so The first one that we calculated was Denver, and the difference in arrival time there is 2 minutes and 20 seconds. So again, we're going to line Scrappy up along the y-axis. We're going to make a mark at 0 and a mark at 2 minutes and 20 seconds. So there it is. So I'm going to slide up to 2,000. I'm going to line my 0 mark. Then I'm going to work my way down until my top mark touches and there it is. So I'm going to bring my Scrappy down, and my distance there is 1,400. All right. Go ahead and practice doing Dallas and Salt Lake City. And go ahead and pause this video, and then we will go over the answers. So you should have paused this video to practice doing the other two. So for Dallas, we have a distance of 2,000. And then Salt Lake City, we have a distance of 1,000. And it's okay if these numbers are a little bit off, because not every single copy is going to be exactly the same. As long as you're within 100 of these, you are okay. All right, so I'm going to go over the last two columns quick, just for Denver, and then Dallas and Salt Lake City you can go ahead and do yourself. So to find the P-wave travel time, it's really quite simple. You're going to use your ESRT, and we have a distance there of 1,400. So I'm going to go to 1,400 on my ESRT. So 1, 2, 1,400. I'm going to go up until I reach my P wave. And then I'm going to go over. And the travel time for the P wave at a distance of 1,400 is 3 minutes and 0 seconds. Now, last thing that we need to do is find the actual time of the earthquake. So to do that, we have our P wave travel time, and we also have our P wave arrival time. We're going to subtract these numbers because the earthquake should happen before a P wave arrives at a location. So we have plus 0 seconds. 24 minus 3 is 21 minutes, and our 5 there is going to remain. So it's 5 hours, 21 minutes, and 0 seconds. Here's a hint. The origin time in this column here should be about the same because this is the same earthquake. It's the same earthquake, and 3 locations recorded the information. Now we need 3 locations to record our earthquake, because now we're going to use our compass to find the actual epicenter of the earthquake. So you're going to want a compass, and you're going to want your pencil. And you're going to flip to the back of their lab to our map that says earthquake number 1. And we're going to use a scale at the bottom here. So on our compass, there are 2 spots that you can place your pencil. So just pay attention to what spot you're going to use. You're also going to line up the bottom here, this straight edge with 0. Okay? We're not actually using the ruler on the top or bottom. We're actually using the key here, or the scale here that's found on our map. So I'm going to zoom into that just so you can see it a little bit better. So our first distance was for Denver, and that's 1,400. So I'm going to line my flat edge here. And again, pay attention to which one you're going to use. You're going to press down, and this slides. So I'm going to use this one right here. So that represents 1,400. All right, and that's for Denver. So I'm going to find Denver on my map. I'm going to place the center of my compass there. And I used this spot, so that's where I'm going to put my pen. So that's our first circle. Somewhere on that circle is going to be our earthquake. So now we're going to do the second location, which is Dallas. And we calculated that distance of 2,000. Now if you take a look, 2,000 isn't on here. So here's what you need to do. I'm going to use this spot this time. So I'm going to slide it out to 1,600, so 1,600. I'm going to slide my ruler over. So that was 1,600, 700. Oops, sorry, we're going to have to use the second pencil spot. So I lied, we're going to use the second one here. It's just not quite big enough. So that represents 1,600. We're going to slide it over. 1,007, 8, 9, 2,000. So now this represents 2,000. And this was for Dallas. So I'm going to place my compass on Dallas, and we used the second spot again. And this time you don't actually have to draw the whole circle. You only need to draw where it meets the first circle. So either our earthquake is going to be in this spot or in this spot. So our last seismic station is going to help us find the actual epicenter. So for Salt Lake City, our distance was 1,000. So again, you're going to line up your compass, and I'm going to use the first one this time. I'm going to line it up at 1,000. And that's at Salt Lake City. All right, so we have our 3 circles. And let's zoom into that so you can see. So sometimes the circles don't always meet right in one location, and that's okay. If they do, awesome. If not, that's okay. See this little triangle here? That means the epicenter is right there. I'm going to place an X there. This other triangle that was created is too big, so you want where the 3 circles are the closest together. So that means that our epicenter for this earthquake is near Los Angeles. So that's how you find the actual epicenter of an earthquake. You need 3 seismic stations. You're going to find the P and S wave arrivals. You're going to find the difference, or the lag time. You're then going to use your ESRT, page 11, and Scrappy to find your distance. And then you're going to use those distances to draw your circles with your compass. And remember, you can either